Good morning. My name is Matt Hiatt. I'm the IT Director with Palmetto Care Connections. I'm here with David Geddings, Telehealth Engineer with the South Carolina Telehealth Alliance. We're here to talk to you about the technical aspects of telehealth equipment in your organization and across the state. Some of the benefits of telehealth are brings care to the patient where they are, faster access and reduced delays, fewer missed days at school or work, decreased ER visits, improved chronic disease management, decreases stress on families, improves outcomes due to less missed visits, reduces overall healthcare costs, including time, travel, increases satisfaction of care, and improves health outcomes. So a little about the telehealth protocols used across the state. H.323. It defines 4 types of components which deliver point-to-point and point-to-multipoint multimedia communication services. The components are as follows. Terminals, so client endpoints that deliver bidirectional and real-time multimedia communications. The H.323 terminal can be a computer or device that runs H.323, so software and hardware-based codecs. Some examples of those are Polycom and Cisco. Gateways, used to connect 2 distinct networks. So the H.323 gateway can provide connectivity between H.323 and non-H.323 networked devices. The gatekeeper. The gatekeeper serves as the core point for every call and provides endpoints with call control services. The MCU, multi-point control unit. It delivers support for conferencing 3 or more H.323 endpoints or terminals together. Each terminal participating in a conference sets up its own MCU connection. And all of these services, the H.323 services, are available through PCC and our providers of the rural and underserved areas in South Carolina. SIP, or Session Initiation Protocol. Most of you are probably familiar with this in your environments already today, but SIP is a text-based signaling protocol that establishes Internet Protocol network sessions. SIP was designed in 1996, which is along the same lines of when H.323 was designed, and approved by the Internet Engineering Task Force. It's used for voice over IP calls. It utilizes UDP and TCP and is used for live stream video conferencing or voice calls. It is also, the infrastructure to run SIP is also available to the providers in the rural and underserved areas of South Carolina through PCC. Web real-time communication, so WebRTC. WebRTC is an open platform. It provides real-time media communication, so voice, video, and data, transfer between browsers and devices, ability to communicate within a primary browser without the need for additional software or plugins in that browser, generally accepted by most all browsers, mobile and PCs. These are a few examples of the type of carts that are across the state and are available, generally available for folks in the state to choose from to be placed in their environments. The Ironbow Clinic cart can have either the Polycom or Cisco hardware-based codec in it, as discussed on previous slides. The Amwell cart comes with a Cisco SX20 in it, and you can utilize H.323 and SIP protocols, as well as the Ironbow Clinic cart. The Cybernet touchscreen PC and or tablet-based carts both run Windows 10 and are just simply a PC, and can run applications that utilize H.323, the SIP protocol, and allows for WebRTC utilization. The Amwell cart and the Ironbow cart will run H.323 and SIP, but do not work with WebRTC applications. The last cart here is just another PC-based cart put out by the SCTA and MUSC. It's called the OP2 cart, Outpatient 2 cart, and also itself runs a Windows 10 operating system and can run the H323, SIP, and WebRTC protocols. Some of the peripheral devices that are generally available across the state and work with all forms of the carts on the previous slide and shown here on your right. The horoscope camera and the horoscope lenses shown below here is the lens that are used to have your primary care visits and visits with your provider. You have a general exam cam, an otoscope, a derm cam, and then a fundoscope. There are many other lenses that goes with the horoscope for just about any type of care or service that you would want to provide, but these are the lenses that are typically used, and probably more so the general exam cam lens and the otoscope across the state today. What you have here are two examples of stethoscopes that are readily used across the state as well. There are other flavors of stethoscopes, and it just generally depends on the user and what they are comfortable with as to which stethoscope they choose to use. So I want to introduce you now to David Geddings. He is going to go through the OP2 cart that is put out by SCTA and NUSC.
Welcome to this training module on the new version 2 of the Outpatient Telehealth Cart. This module will be an overview of the new Outpatient Telehealth Cart, also referred to as the OP2 cart. The OP2 cart is the newest version of the telehealth equipment with enhanced functionality for providers and end users alike. This cart was designed and built in-house by the Telehealth Technology Team, commonly referred to as TTT, of the Medical University of South Carolina, MUSC, and the South Carolina Telehealth Alliance, SCTA, with input from clinical staff, telepresenters, patients, and providers of telehealth services. Improving patient access to telehealth services begins with providing telehealth equipment to as many sites as possible. Rural South Carolina has many opportunities to improve healthcare access and services. Commercial telehealth carts come with high costs, which reduces MUSC and SCTA's ability to deploy a large number of endpoints. Using the knowledge, the Telehealth Technology Team designed and built an affordable telehealth cart which can be deployed to more South Carolina healthcare sites, resulting in improved patient access and to healthcare services. The design and implementation of the OP2 cart began with knowledge gained from supporting hundreds of telehealth endpoints throughout the state and with the user experience from existing telehealth programs. Functionality of previous versions was detailed as to what worked and also to identify issues with previous telehealth carts. After factoring in cost, combined with features and functionality, a design was created for the development of the OP2 cart. The cart reduces hardware and maintenance costs by over 60%, has a standardized configuration, and requires lower bandwidth to operate. These efforts allow us to build and deploy more telehealth endpoints for rural communities. Designing, deploying, and supporting the OP2 cart is one way that we can effectively respond to the health needs of South Carolina citizens with an emphasis on those living in underserved and rural areas. Additional carts in rural areas address the healthcare access needs of rural citizens and provides rural providers with access to medical specialties. The major components of the OP2 cart include an all-in-one touchscreen computer and a Logitech Meetup high-definition camera mounted on a custom-designed battery-powered cart from Simplify. An overview of the cart and all its components will now be demonstrated. First, let's look at the chosen cart. The cart is a battery-powered and developed by Simplify. It's called the EVA model for its ease and functionality. The cart can run on battery power for up to 40 hours. Yes, 40 hours without a charge. The cart has electronically controlled console buttons for cart height, multiple lights, and separate power for the attached computer. The current design is using a Dell all-in-one computer running the Windows 10 operating system. The operating system allows for multiple forms of communication software such as video, Cisco Jabber, WebEx, and the WebRTC clients, which are found embedded in the most common computer browsers. The choice of camera is the Meetup by Logitech. This camera is an all-in-one conference camera that has an ultra-wide field of view, which is 120 degrees. The camera has a 5x digital zoom as well. With its motorized pan and tilt controls, it can even further widen the field of view. There is a mounted camera remote on the surface of the cart. However, most controls of the camera can be manipulated from within the chosen video application, including far-end camera controls, also referred to as FECC. The camera's integrated audio is optimized for close-quarter acoustics and delivers an exceptional sound experience. There are 4 highly directional microphones and a custom-tuned speaker that helps ensure that each console has high-quality sound with echo cancellation. To power on the cart, first plug in the coiled power cord into the wall outlet. This will begin the process of charging the battery in the cart. As mentioned previously, once the battery is fully charged, the cart can operate for up to 40 hours before it needs a charge. The console on the cart will boldly highlight the amount of remaining battery time on the cart's console. Once the cart is plugged in, flip the toggle switch in the back of the cart just above the power cord to send power to the cart. To power the attached onboard computer, press the PC power button on the cart's console. Next, press the power button on the Dell all-in-one in the bottom right of the computer. The computer will boot and log in automatically. Next, you will need to connect the computer's operating system to the wireless network of your choice. Once the wireless network is connected, you can activate and log into your video application of choice. Bear in mind that you should only have one video application running at the time on the computer, as they consume large amounts of resources on the computer and will sometimes lock up the camera to only a specific application. Now that we've discussed the overview of the cart, let's look at some of the medical peripherals that you can offer on the cart. Many medical peripherals can be added to the cart to enhance the console. The options are endless on the OP2 cart in regards to peripherals. However, the most prominently chosen peripherals are the horoscope and the stethoscope. Let's do a deep dive in each of these now. The horoscope, designed specifically for telehealth by GEDMed, is an easy-to-use handheld video system used for capturing images of the body. This system utilizes interchangeable lens attachments, making it ideal for multiple discipline medical application. The primary lens attachments used with this cart are the general exam lens and the otoscope lens. The horoscope incorporates a high-resolution 1080p camera and offers multiple video output options for integrating into your chosen video application for your console. To power on the horoscope, press and hold the small button on the top left surface of the LCD screen. The LCD screen will illuminate and display the manufacturer logo. After about 15 or 20 seconds, you will see the camera image and you are ready to use the horoscope. The power indicator light on the horoscope handle will inform you as to approximately how much battery life and charge you have left on the device. If the light is colored blue, the battery is more than 25% full. If there is an orange-colored light, then the battery is in need of charging. If there is no light, then either the unit is off or not connected to the charging cable. The image can be focused from the horoscope handle. There are two models of the horoscope, and one model has a turn wheel underneath for your index finger, where the other model has a digital zoom buttons on the front of the handle. There are also brightness adjustments to the horoscope that range from 0 to 10. These can be controlled with the buttons on the front of the handheld. To mount a horoscope lens, find and match the black lens alignment dots on both the horoscope and the lens attachment. Insert the lens into the horoscope's connector interface. Rotate the lens attachment gently in a clockwise direction to fasten the lens until it stops. This is similar to a DSLR camera lens attachment. For the purpose of this demonstration, let's do a lens attachment overview, which we will highlight the general exam lens and the otoscope lens since these are the most popular. The general exam lens attachment is used to meet a variety of needs that require wider angle views of the body. This attachment has built-in LED technology providing excellent illumination and color reproduction. Some common uses of this optical lens will be wide-angle views of burns, viewing the teeth and mouth, and any other areas of the body that a basic examination may be required. The otoscope lens attachment is used for viewing images of the ears and nose. This attachment has built-in LED technology providing excellent illumination and color reproduction. It is designed to use a variety of ear specula. Here are just a few other notes regarding the use of the horoscope. The live video and images from the horoscope will be slightly less than real time when remotely transmitted to the distant provider. Once it is clearly focused on the location in, hold the shot until the remote provider advises to move to the next location. If the patient is susceptible to movement, focus on something else close with the camera before attempting to focus on the patient's area. This will reduce the time on patient by only needing to make slight focal adjustments. This concludes our overview of the horoscope. Next, we will review the ThinkLabs 1 digital stethoscope. The ThinkLabs 1 is a small, bell-shaped digital stethoscope made specifically for telehealth. There are three main components of the ThinkLabs 1 stethoscope: the ThinkLabs 1 digital stethoscope, a white USB to 3.5 millimeter charging cable, and a black 3.5 millimeter to 3.5 millimeter transmit cable. In reference to the cables, bear in mind that white cables are for charging and black cables are for transmitting signal. Since there is only one port on the stethoscope, the telepresenter needs to be aware of which cable is connected, as it will not transmit the sound while connected with the white cable. The ThinkLab 1 digital stethoscope is powered by an internal rechargeable lithium-ion battery. The stethoscope will usually be shipped with a partial charge. The unit should be charged fully before using it clinically. A full charge should provide over 4 hours of use. To charge the ThinkLabs 1 digital stethoscope, connect the 3.5 millimeter end of the white USB charging cable to the ThinkLabs 1 stethoscope. Connect the USB end of the white charging cable to a powered USB port on the cart. When charging, the battery LED light will flash. As the battery charges, the flash rate will slow. When the battery is fully charged, the LED light will be solid and stop flashing. A thorough charging cycle can take as long as 8 hours. However, your stethoscope should have almost full capacity within 4 hours. Now that we have the ThinkLabs 1 stethoscope charged, let's connect the black transmit cable for communications. The ThinkLabs 1 stethoscope has 4 keys or buttons which control all the functions of the stethoscope to include power, volume, and filters. To power on the ThinkLabs 1 stethoscope, press and hold the top right key and LED lights on the display will light up. To power off the ThinkLabs 1 stethoscope, press and hold the bottom left and top right keys together. The stethoscope will automatically power off after a preset number of minutes. By default, this time is 1 minute. The preset time can be changed by turning the stethoscope on and pressing the top right key the number of times for each minute of shut-off time, and then pressing and holding the top right key until the device shuts off, which will be about 10 seconds. To control the volume, use the plus and minus keys along the bottom of the stethoscope. The display will show the volume on a 0 to 10 scale. Do not listen at excessive volume. If you have normal hearing, you should seldom need to use a volume level in excess of 5. Press the top left key to switch between the 2 favorite filters, which are the bell and diaphragm. Any current selection, bell or diaphragm, will become the favorite and is saved when the stethoscope powers off. Finally, when using the ThinkLabs 1 digital stethoscope on a patient, there are a couple of recommendations to make the signal transmission more receivable. The stethoscope must be in direct contact with the patient's skin. It will not transmit through clothing. The outer side of the stethoscope should not rub against clothing, as this will add unacceptable noise to the signal transmission. The local provider should cup the stethoscope in their hand to apply to the patient, so as to prevent it from rubbing on anything externally. If the stethoscope is attached to the cart, all other microphones should be muted to prevent additional external noise from being received by the remote provider. This concludes our training on the OP2 cart and its peripherals. We want to thank you for taking the time to observe this training module on the new OP2 cart. We hope it was both informative and beneficial in preparing for your future in telehealth. If you need more information on the OP2 cart, you can contact the MUSC and SCTA's telehealth technology team through our telehealth service portal at sctelehealth.service-now.com. Again, we want to thank you for participating.